Okay, let's take another example of how to model this glass pot design. First, before that, I just seen that the exact drawing. In this drawing, look at it, the isometric view clearly projects what is the exact pot looks like. And there is a top view, section view, also the side view. In the section view, it is clearly indicates the different types of dimensions based on that area. Now, based on this recommended dimensions, we going to model this pot design. Okay. The important note is this section view. This only have a clear dimensions with the horizontal dimension as well as the vertical dimensions. That is a dia as well as the vertical dimensions. If you want to know the angle of between each instance means we can clearly see in the top view. Okay. First we are going to model the exact section view areas. So first select new part design. All the designs comes to part modeling itself. So I select a part design. Then choose front plane. Why I am choosing this front plane means if you take this view into an isometric section means this view will clearly project into an isometric because we cannot going to model this design in a top view. It is not projected well on that kind of sections. Okay, first I am just drawing this outer profiles to make the shapes aligned with this and proper dimensions. Okay, that's why I am drawing this both horizontal profile as well as a vertical profile. Now using a 3-point arc to get a clear pot design. We just draw this profile first, then using a smart dimensions to fix it with this both horizontally as well as vertically with help of origin points. That's why I am drawing this vertical construction line. Take it as a center axis. Now using a smart dimensions to fix these profiles. First the overall profile. Start point and end point. Before that we can clearly know what is the exact dimension of it. This dimension is the vertical one is 71 mm. First selecting this both end points and just mention it is in 71 mm. Next the horizontal dimension, that is end to end dimensions. First one end to end dimension is 71. Next second is 25 mm. I horizontally fix it. Next one by one each point will fix it. Once you fix all the end points, it will clearly constrain the overall profiles. Now the other horizontal lines. Just fixing this end points itself. It is 17.5 mm. Next another horizontal line. It is just 28.25 mm. Next now going to fix this arc profiles. Before that I just fixing this top end as well as an bottom end. First I am fixing this bottom end. This vertical dimensions. It is a simple profile. That's why I am using only vertical constraints, that is in vertical dimension as well as in horizontal dimensions. If it is an arc, you can straightly choose a radius to fix this areas. It is easy to fix this end point. That's why I am using this type of constraint areas. Then only arc is enough to fix. Look at that. Now my profile is fully defined sketches. We cannot able to deviate these sketches. We only able to edit the sketches using values. Okay, now the profile is drawn. Next using revolve both options to make this profile into a solid body. Look at it. It is exactly forms like a pot design. We need to make a neck on this top of the sections. Also create some of this patterns, other side areas. That is the only thing we need to do. Okay, now we are going to model this instance. Before that, we just see in this section view. This is clearly indicates what is the exact dimension of it. Also look at this top view. We know what is the exact profile and the angle of it. Okay, now go to the SolidWorks again and draw this profile. I'm just making using SolidWorks options to make the solid features. So first to draw the profile. That is a path curve. Using a 3-point arc to draw the profile. That is start point, end point and the midpoint. Then fix this start point and end point using a dimensional constraints, both vertically as well as horizontally. First, end point was fixed with this and base portions using coincide options. Next, the only thing is we need to fix at the top point. So using a dimensions to fix this end points now. Okay, now I just to show this previous sketches to know what is the exact dimension of it and easy to fix with this end point. So using a smart dimension, selecting the previous sketch end point, next the current sketch end point with the vertical dimension of 10 mm. Okay, next the only thing is we need to arrest with this radius points. So just fix it with this radius of 42.7 mm. Okay, now the path curve is created. Next we need to draw the profile. So now exit the sketches. If you want to draw the profile, first I just hide the sketches. This how the path curve looks like. Now we are going to make only the profile, that is a sketch profile to make this area. First is selecting the plane and create a plane at the center of its portions, because I just need to draw from the center of its area. So selecting the faces from the base area and selecting this center point. Once I selected, a plane is created at the center of its spot. Now select a plane and create a sketch, draw the profile. Now I just need a reference sketch to draw this 3-point arc without any deviation. So I am just making this arc profile into a line. Look at this, in this top line it is almost look like a line. So I am just selecting this profile and use the convert entities options to make this line as a reference entities. Now I am going to draw a 3-point arc. Using a 3-point arc, I just draw this profile. That is a start point, end point and the midpoint. Now fix the sketch at the center point area. So selecting this arc center point now and the end of its construction lines. Okay, now the center point of this arc profile are fixed at the center of this construction lines. Next we need to fix with this smart dimensions. That's why I am going to draw another arc profile, because in this top view we have only one dimensions are recommended to fix this area, that is an angular dimensions. That's why I am drawing another arc profile. Next, make this arc profile as a construction line, because we only need a arc profile that is from the origin area itself. We no need an additional arc profiles. Then draw a construction line at the center of its second arc. Then using as dimensions to fix this line with the angular dimensions. Selecting line and selecting the endpoints, the quadrant is now created. Selecting this particular arrow mark to fix it with this smart dimensions, that is an angular dimensions. Okay, now the arc is positioned. Next I want to align with this an exact dimension. So I am just need to draw another circular profile. Just to draw another circular profile at the center of its point. Next to fix this arc and circular together. Selecting the arc and the end point coincide with each other. Next, select this circular profile, make it into a construction line. Then selecting this construction line, that is an arc profile, tangentially fix this areas or coincidentally fix this areas. Then using a smart dimensions to fix this exact area. That is the only thing we need to do now. I'm just using an horizontal dimensions to fix this arc. Look at it, now the arc is fixed. Just using a dimension of 20 mm. Profile is drawn. Next we need to create it using a swept to both options. Then making this circular edges as a sketches using a convert entities options. Why? Because I need to close this arc profiles. That's why I'm making this edges into a sketches. Then using a trim entities to trim this excess entities, make this arc profile into a complete closed sections. Look at it. Now the closed contours or appears. That is shades forms or appears. It indicates our sketches is now closed. Then using a swept to both options to make a solid body. First is the sketch profiles. Next one is a path curve. Once you select the path curve, there are some of the options or indicates. That is either from direction 1 or directions 2, or you can select in both directions. I choose both directions because I need both the areas is to be patternized. This is selecting this both directions, solid body or created. This pattern looks good in this views. It is easy to make with this kind of an options. That's why I'm using this method to solve it. Okay, next we need to create a pattern. Before that, we just make this sharp edges into a smoothen one using a fillet options. Make it into a specify radius and selecting this edges. Once you select the edges, automatically the fillet forms. Now it is tangentially connected within each other. That is from the base body to the instance area. Next, pattern these areas. Now, first selecting the sweep bodies, then fillet bodies. Choose a patterns, circular pattern. In circular pattern, either you can choose the circular edges or you can select this axis. It's enough to make this instance. I am just selecting the circular edges to make a pattern. Then increase the numbers, whatever you want. Just pattern this distance with an equal number of an angle by selecting equal spacing options. Choose whatever the instance you want. Based on your instance, the angle get equally splitted. Okay, now the instance are patternized using a circular pattern options. Look at it, how our handle looks like. The pot design are exactly looks like same as like our drawing. We need to only create a neck at the top of this portion. That is the only thing we need to complete the overall pot design. So I am selecting this front line and going to draw this neck area. Using line profile to make this profile formations. First, I complete this profile and using a smart dimensions to fix this exact area. Just using a line profile to complete this overall profile. Look at it, this is our exact profile looks like. Next, using a smart dimensions to fix these areas. Selecting it. You just need to fix both the horizontally as well as vertically because there are no need of using a radius. There is none other than no arc is specified here. Just I am using only a line profile to draw this area. 8.5, that is a vertical one. Next to the horizontal line. Defaultly, the point are fixed with this an origin area. That's why I am using only a dimensional constraints to fix this area. Otherwise, we need to use both the dimensional constraint as well as some geometrical constraints. Now look at how it looks in this section views. This is the exact dimensions of how we created from the sectional areas. Same dimensions are used in this dirt portions. The dimension is correct now. Next, I need to make a solid body using revolvable features. Go to the solidworks again. Exit the sketches now. Profile is now corrected. And using revolvable options to make these features. Select this and choose this vertical line. Neck is created. We need to create a shell formations at the inner section areas. We no need to use the shell formations because there are some kind of profile formations or at the inner side of the areas. We just recreating the profile again to the sections to make a cut, revolve cut. Okay, just drawing or show this previous sketches. Recreating the profile again using a line profile. First draw the baseline, horizontal and the taper one, same as like our previous sketches. Just to draw same as like that. All the thing are same except the arc profile. Now drawing the vertical line exactly coincident with this default origin points. Horizontal. Now again vertical line similar to our previous sketches only. Now the only difference is this arc only. Start point, end point and the midpoint. After you fix it, you need to give a dimensions. Because profile is drawn now, next to fix it using a smart dimensions in this area. That's why I am drawing this profile. Now I am using smart dimensions. The horizontal one. With this just 24.25 mm. Next to this vertical area. This is just 1 mm. Next, the bottom of this line also the end point is just 1 mm. Again the end point of this top area also 1 mm in horizontally. Then selecting this line, geometrically constrain with this exact sketch using a parallel options. Okay, now the sketch is fixed at the bottom of these portions. The top portion also almost corrected. Before that, we get a clear drawing. In this section view, there are no radius or appear here, but if you section these views, the arc are slightly closer than this outer profiles. That's why I am not drawing any kind of a profile randomly or using a shell features to make this solid formations. Just drawing this profile and clearly offset from a 1 mm distance. This 1 mm is this thickness of this part design. If you section this overall part, the section view almost a thickness of 1 mm. I think the profile is not completed well, so I am just undo this profiles and make it into the exact radius, whatever we want. Just selecting this endpoint. In this arc profile, we no need to use this radius to fix this arc. We just using an smart dimensions to fix this endpoint and fix this arc portions. Look at it, how I fix this area. I'm using a smart dimensions to fix it with this in vertically. First the endpoint, top endpoint, it is just a 5 mm in vertically. Look at it. Now the bottom endpoint. It is almost closer to our default profiles. Now I just selecting this dimensions and delete it. If I try to fix this arc profile, it is not fixed within each other because it is not fixed exactly to its radius. Because if you apply any kind of radius, the endpoint are not arrested. Look at it, it is deviated. I need to fix this endpoint first. Then only we can complete the section areas. Just using a smart dimensions again to fix this endpoints first. First I selecting this endpoint on a horizontally fixed within each other. Once you select it, now look at this profile. It is constrained. This is the only thing we need to do in this profiles. Now the profile is completed. This is how we need in this section areas. Okay, now I just hiding this previous sketches. Using this exact sketch to make a revolve cut. Choose revolve cut options, select this vertical line as an axis line and make a cut with the 360 degree. The part sections are exactly created. The only thing is we just make a revolved boss options and revolved cut to make a part. Also create a number of the instance using swept boss options. Then smoothen all similar edges, that is to sharpen edges into a tangential one. Now the outer edges, just selecting this outer edges with the fillet expert options. Why I am just using a fillet expert option means we can use different kind of radius in different edges at one time. First I am selecting one of the edges with a different radius, apply it. Next I am using another radius with another edges. One options with the multiple number of radius, we can apply it using fillet expert options. Choose whatever the edges you want. Make all sharpen edges into a smoothen one by using this fillet curve. Select all edges, whatever the edges it is. Select it and make it into a fillet formations. Choose enough radius, whatever you want, apply it. Then the radius is applied, the part exactly completes. Just using revolved boss options, afterwards make every area into a smoother one using fillet options. Now look at this in section views, it is exactly similar to our sectional sketches, that is our default sketches. Same as like our 2D sketches, the section views are created. That's why I am not using a shell option in this area. Using a profile again to make a revolve cut to form this part features. Okay. We completed this part profiles. Make it into an isometric view. That's why I am using front plane.